lecture, we are going to see one of the most famous and most studied iconic games of game theory, which is the prisoner dilemma. Two criminals are caught red-handed while snatching an old lady's handbag. This crime is punished through 2 years of prison. But they are suspected to be responsible also for a major crime, which is punished through 10 years of prison. The issue is that the police doesn't have enough evidence to accuse them also for the second crime. So, the chief superintendent has the idea to separate them and then proposes to each separately to grasp on the other in exchange for a reduction by half to the bank snatching penalty. This is the starting point situation of the prisoner dilemma. Let's use the game theory to model this game. We have 2 players, respectively prisoner 1 and prisoner 2. Each player has 2 identical options, which are not confessing the crime of the accomplice or confessing the crime of the accomplice. We are now going to fill in the payoff matrix using as payoffs the number of years of prison. Therefore, in this game, the higher utility is related to the lower number of years and vice versa. If both the criminals do not confess, they are accused for the bank snatches, so 2 years, without any reduction of the penalties. If prisoner 1 is confessing but prisoner 2 not, prisoner 1 is just accused of the bank snatching and is taking advantage by the halving of the penalties to 1 year. On the contrary, prisoner 2 is accused of both the bank snatching and the major crime, for a total of 12 years of prison without any reduction. The game is symmetric for the 2 players, and so payoffs are exactly the same but inverted, also for the case where prisoner 2 is confessing but prisoner 1 not. Finally, if both of them are confessing, both of them are accused of both the crimes for a total of 12 years of prison each. The only positive news is that in this case, the 2 prisoners also take advantage by the reduction of the penalties of 1 year, so the final penalty is 11 years each. Let's solve the game. The first point is looking for dominant alternatives. We could see that for prisoner 1, confessing is a dominant alternative, because if prisoner 2 is not confessing, he would have 1 year rather than 2. If prisoner 2 is confessing, he would have 11 years rather than 12. Being the game symmetric, we could assume that confessing is a dominant alternative for prisoner 2. The second point is looking for efficient solutions. We could see that there are 3 efficient solutions. 2-2 is efficient because moving from to either not confess, confess, or to confess, not confess, situation is improving for one of the player, reducing the penalty to 1, but the situation is much worse for the other, increasing the penalties to 12. Moving to 11-11, the situation is worse for both the players. 12-1 and 1-12 are 2 efficient solutions because moving respectively as well as moving to 11-11 is improving the situation for one player, deteriorating for the other. On the other hand, 11-11 is not efficient because moving to 2-2 situation would largely improve for both the players. Then, the last step is looking for Nash solution. In this case, it's particularly simple because we have 2 dominant alternatives, and so the Nash solution is at the intersection between the 2 dominant solutions. So, we could conclude that the 2 prisoners are going to confess, and so they receive 11 years each. There is no point denying that this was exactly the wish situation by the chief superintendent. We could also notice that this is the only not efficient solution. Any other solutions would improve the global results. Where does this game find a real application in managerial choices? Actually, much more often than what you might expect, and staying always in the legal area, of course. Very often, collaborations with colleagues, partners, suppliers, or customers have the risk to fall into a prisoner dilemma, because the opportunistic behavior is gaining a higher benefit than maintaining the collaboration. This is actually one of the main causes of failure of collaboration in business. Another example pertains to the price war to push out of business the competitors. But if the competitor is doing the same when it would be more reasonable to have a price agreement, they could strongly reduce their profits. Finally, most of the commercial and promotional activities are in that situation as well. It is quite well demonstrated that it will be better for companies to find an agreement and not have price promotion, but just a reasonable price stable over the year, with a reasonable amount of ads investments. In reality, companies are pushing promotions and ads to try to steal market share to competitors, perhaps just losing in marginality. How could the two prisoners move from this tax situation? The situation described before is totally irrational, and so, to change the results, we need to change some environmental variables that are influencing the game structure. To change the environment, we need to put in practice the main concepts of Folk's theorem. First of all, it must be possible to repeat the game. If the game is played just once, players are necessarily encouraged to have an opportunistic behavior. If game is repeated several times, the real payoff is not just those of one time, but the sum of all the payoffs that the number of times the game is played. If criminals are working together steadily, the payoff is the overall number of prison years. Secondly, the future should have a value for both the players. Payoff gained through a single opportunistic behavior should be lower than the sum of the payoffs of several repetitions, obviously actualized to the number of times the game is repeated. Finally, there is the possibility of punishing opportunistic behavior. If a player is not collaborating, the other players are known of that and could punish this behavior accordingly. If a criminal is confessing, the other should know it and operate accordingly. Through this theorem, the payoff matrix is going to change, making much less convenient the case of confess and much more convenient the case of not confessing. Out of real and practical example, the Folk theorem is the basic model that makes working companies such as Airbnb, eBay, and other similar marketplaces.